Hi there again, and in this video we continue with taking in integrals and we'll continue doing so, practicing over and over, looking at different methods, different techniques, how we use substitutions, and so we go through each integral step by step so you can see how the method is applied and how we come up with the answers to the integrals. So I think by the end of this video, we will have at least completed 30 or more different integrals, and there are plenty more to go. So anyway, let's get to it. Yes, we left off at this problem, so we'll pick up the next one. Number 18 in my notes, we're going to take a look at the integral of x squared sine x dx. X to the third, that is, dx. Again, we're going to use a U-substitution for the argument of the sign. So we're going to go U equals x to the third, and du equals 3x squared dx. But in the integrand, all we have is x squared dx. So we have to add to make du, we have to add a 3 and divide by 3. So we are going to erase this, give it a little more room, and we're going to go 3x squared dx, but we have to put a 1/3 out here because we have to make that 1. So now we have 1/3 sine of u du. And we go here to y equals cosine x, dy equals minus sine x dx. And if we go integrand, dy equals minus sine x dx. And we got cos x equals minus sine x dx, then minus cos x equals sine x dx. So here we have minus or 1/3 or minus 1/3 cosine of u plus c. And that is equal to minus 1/3 cosine of x cubed plus c. And that's our answer. And it may seem like we're doing a lot of repetition, but practice makes perfect. Plus, you can see where it makes sense to make a substitution and where it doesn't. So here we got another one, and this one's pretty interesting. We got secant to the fifth times 5x, or secant to the fifth of 5x dx. So let's first substitute the argument. So we have, okay, u equals 5x and du equals 5 dx. But we don't have 5 dx, so we put 5 here, 1/5 out here, and this is equal to 1/5 secant to the fifth of u du. And now we take a look at our, where did I get this problem from? 5x. Oh, you know what I did? I misread that one. I'm sorry. I misread it. We're not ready to do this one yet, this power. We're going to make that a square. I apologize. So this is secant squared. I misread that as a 5. I must be needing better glasses. So we start out with y equals tangent x dy equals, now when we take the derivative of tan x, it's secant squared x dx. So if we take the integral, dy equals the integral of secant squared x dx, we have y, which is tan x, equals secant squared x dx, and that's what we have here. We have 1/5, and this will be tangent x, u, sorry about that, u plus c. But u was 5x, so that's tangent 5x plus c. And that's our answer. I thought we were going to start really doing some pretty cool stuff, but not quite yet. Secant is kind of an interesting function to integrate later on. You'll see as we progress in our methods and ways of integrating. So here we go. We got another one. We got x to the fourth secant squared x to the fifth dx. And again, we use a U-Substitution. U equals x to the 5. And du equals 5x to the fourth dx. Well, we have x to the fourth. What we don't have is 5. So we add a 5 take a 5 out here, 1/5. And we have secant squared u du. And that, as we'd seen before, is 1/5. Forgot that. 1/5 tangent u plus c, and that's equal to 1/5 tangent x to the 5th plus c. And that's our answer. It's good to do lots of these so that you have practice. So now, here we go. We got sine of 4x times cosine 4x dx. And here we're going to do two substitutions. We're going to do a U-substitution for the argument of the functions. So we're going to go u equals 4x and du equals 4 dx. And we don't have 4 dx, so we go 1/4 sine u cosine u du. Because we add a 4 and we take 1/4 out there, and now we have sine of u, cosine of u. So now let's make another substitution. Let's say z equals sine of u. dz equals cosine of u du. So here we go. We got 1/4 z dz. And that is simply a polynomial. We're not talking about a trigonometric integration here. We're talking about a polynomial integration. So we have 1/4 z squared over 2 plus c, and that's equal to 1/8 z squared. So z is sine squared u plus c. And now our final answer is 1/8 sine squared. Now we had 4x as u plus c. And that's our answer. Everything's copacetic. And we're moving on to the next page. So let's take a look at what we have to come. I have 30 right now altogether in this set. So we'll just continue on. It's good practice. Here we have the integral of sine of x to the 3rd x squared dx. And we can see right off that we're going to be using a U-substitution for the argument. So we got U equals x to the third, du equals 3x squared dx. So what are we missing? We're missing 3. So 3, and then we take 1/3 out here. And now we've got u du. So this is equal to 1/3 u sine of u du. And we know from our trigonometric integrations that this is equal to 1/3 or minus 1/3 cosine of u plus c, and that's equal to minus 1/3 cosine of x to the third plus 3, or c. Can't forget, because these are indefinite integrals, we can't forget the constant c. And there's a way of solving these for these constants in their initial conditions, but we haven't got any initial conditions yet. So, for example, if we said that at x equals 0, y, and this is y equals 4, then we'd have equals minus 1/3 cosine 0 to the third, so cosine of 0 plus c, and y equals 4 equals minus 1/3 times 1 plus c. So now we can solve for c. C equals 4 plus 1/3, and that's 12/3 plus 1/3, which is 13/3. That's what c is. So we can, if we had this condition, then we would have y equals minus 1/3 cos x to the third plus 13/3, and that's how it would be handled. So that's what the c stands for. You figure that out during the initial conditions. But that was a completely arbitrary example. But in problem solving, sometimes the initial conditions are given. So now, here we move on to our next, and we got, this is one we've done before, didn't we? Yes, I think it is. Yes, I think it is. Maybe not. Let's just do it. We got secant squared 5x dx. And this is the problem we're given to solve the integral. And again, we look at the argument, u equals 5x, and du equals 5 dx. And so dx, we don't have 5 dx, so we go 5 1/5, and so that's equal to 1/5 secant squared u du. And now we can, from our knowledge of trigonometric functions, if we had y equals tangent x, and we go dy equals secant squared x dx, and then if we took our integrands and we got tan x equals secant squared x dx, and that's what we have. So this is 1/5 tangent u plus c, and we substitute back in. We got 1/5 tangent u, which is 5x. We are going to add another now, here we go. Let's take a look at sine squared p cosine p dp. Oh, you know what I did? We're gonna start this again. I read the wrong line. 4x cosine 4x dx. And we have, now we use a substitution. We're going to use p equals 4x in this one. dp equals 4 dx. So we don't have 4. We have, well, you know what we do? We substitute right here. We go sine squared p cosine p, and dp is, dx is dp on 4, so we got dp on 4, so 1/4. So we've done the p, the argument substitution, and now let's do a u substitution for the integrand. So we go u equals sine of p, and du equals cosine of p dp. And we have that, so we have equals 1/4 u squared du. And now we use our polynomial, 1/4 times u to the third on 3 plus c, and that equals 1/12 u to the third plus c, but u is sine p, 1/12 sine to the third p plus c, and then p is for x. So we got 1/12 sine to the third 4x plus c. And that is our answer. That one took 2 substitutions. One for the argument and one for the integrand. And let's see, we're running down close to, this is a cool one. So let's, did I pick, yep, I picked my pen. Okay, here we go. This is a pretty neat one. We're given the integral 3x minus 2 dx. And what is that equal to? Well, first off, let's substitute u for 3x minus 2 du. Whoops. I must be tired. I still am suffering from having been up till 4 o'clock in the morning. We had an emergency last night. I had to go to the animal hospital and unfortunately put our kitty down, so we were up all night. It was a very sad thing. We've had her for many years. So du is 3 dx. And so we put in our substitutions, 1 on u, and dx is du on 3. So we have 1/3, 1 on u du. But when we remember the integrals that we did, this is equal to 1/3 ln u plus c. And then we go back and substitute u, 3x minus 2 plus c. And there we got it. You're moving right along here. There are so many integrations, so many that we're going to do. You're going to be sick of integrating. Okay, so here we go. This is an interesting one. E to the sine squared x sine x cosine x dx. So we're going to make a substitution here. U equals sine x. And du equals cosine x dx. And so this makes this e to the u squared u du. And then we make another substitution. We go z equals u squared and dz equals 2u du. And so we have now a new form, e to the z u du. So u du equals dz on 2. So that's dz on 2. and that's equal to 1/2 e to the z plus c. And that's equal to 1/2 e to the u squared plus c. And that is 1/2 e to the sine squared x plus c. And that should be the answer. That is correct. Oh my. So here we go. We're really cranking through. We've done 30 integrals so far. We're close to it. Okay, let's take a look at this one. This one looks pretty interesting. Here we got 1 over a plus bx squared dx. So we're going to say u equals a plus bx du equals b dx, and we have u to the minus 2, and dx is du on b, and that's equal to 1 on b u to the -1 on -1 plus c, and that's 1 minus 1 on b, 1 over u plus c, and minus 1 on b on a plus bx plus c. And there we go. That's our answer. And we move on to the next integral. This one is a little bit more, it appears a little more complicated. E to the x on 1 plus e to the x dx. And let's try u equals 1 plus e to the x du equals e to the x dx. And that's what we've got here. We have du on u. And that is ln u plus c, and that's equal to ln of 1 plus e to the x plus c. And I think, yep, that's all there is to that one. It's a short integration. Now, I think 30 is my last one. Let me just scroll. Oh, oh my gosh, we got a whole page more. All right, so I was mistaken. We got a number more that we're going to do. Okay, so in this problem, we're given e to the 2x on 1 plus e to the 2x dx. Well, that's not too different from the one we just did. So let's take a we're going to do two substitutions. We're going to say P equals 2x, dP equals 2 dx. So we have e to the p, and 1 plus e to the p, and dx is dp on 2, and that is equal to 1/2, and we're back to the problem that we had before. So then we do our substitution. Z equals 1 plus e to the p, dz equals e to the p, dp, and we have 1/2 u. Let's see. 1/2 1 over u, or z, that's not a u, z, and that's dz, and we have 1/2 ln z plus c equals 1/2 ln 1 plus e to the p plus c, and our final answer is 1/2 ln 1 plus e to the 2x plus c. And that's our answer. Now we're closing in on our last pages of problems. Here's another one that looks pretty interesting. These are all variants of the same theme. So here we're given cosine 3x over 1 plus sine x plus 2 sine of 3x and dx. So we're going to first substitute the argument in the trig functions. So we got 3, u equals 3x, du equals 3 dx, and so we have cosine u over 1 plus sine u, and dx is du on 3. And now we do another substitution where we say that, let's say k equals 1 plus sine u, and dk equals cosine u du. And we have that. We have cosine u du, which is dk, and that's on top of k. And that gives us ln k plus c. And then we have 1/3, and we put our substitution in here, 1 plus sine u plus c, and then our final 1/3 ln 1 plus sine 3x plus c. And let's see what we got there. Oh, you know what I forgot? Oh, boy. We'll have to, right here, I screwed up. That's 2, and that's 2. So that means dk on 2 equals cosine u du. And that would be 1/2. And this, we would have to do a little erasing here. This is, okay, I think we can straighten this out. Oops. This is going to be 2. Plus 2 sine u, and this is 1/6, and 1/6, and 1/6, and 1/6 ln of 1 plus 2 sine 3x plus c, and that's our answer. Sorry. You see, you have to be careful. That's where you saw what happened here. I forgot the 2. I should have a 2 there, and I didn't put the 2 there. And that screwed me up when I made my substitution. So don't make that, you see, that you have to be careful when you take a look at these things. I'm probably a little bit tired from the late night, but that could be part of the reason my eyes are a little blurry right now. But we got the right answer in the end. We caught the problem, and again, it was a mistake. You don't want to make that same kind of mistake, and that's why we do these. And ultimately, we caught our mistake, and we put it, we set the record straight. Now here we got another problem. We've got secant squared of 2 plus 3x, 2 plus 3x dx. This one we want to find a substitution for the argument of the secant. 2 plus 3x du equals 3 dx. And so dx is equal to du on 3. And then we have secant squared u du and 1/3. And this, as we all know, is the tangent of u plus c, which is equal to 1/3 tangent of 2 plus 3x dx. Oh, what am I doing? You can see I'm getting tired. Plus c. What am I doing? Plus c. There we go. And that's our answer. may have to call it quits. This is not, even though I had an ambitious day here, it wasn't the best day for me to pick to do this because of the fatigue. And my wife is napping right now because of such a late night. So let's keep moving along, and let's see if we have any more interesting problems. Here's one. That looks pretty cool. You can see I'm a little bit. Okay, x plus 3 over x squared plus 6x plus 1. So this is kind of interesting. Can we factor this? Is this a factorable problem? Well, I don't see anything that would allow us to factor neatly. We won't end up with two positive signs like that. I mean, if we had x plus 3 and x plus 2, we'd have x squared plus, well, that would be 3x, and that would be 6x plus 9. And if we took a minus, we'd have x squared minus 9, which is not what we want. And if they were both negative, that would be x squared minus 6x plus 9. So there's no way that we can find, there's no way that that can be factored. So that's out of the question. So why don't we just take the whole denominator and make that a substitute here. So we have x squared plus 6x plus 1 du equals 2x plus 6 dx. And now that is, what do we have here? That is twice, and I forgot my dx here. This is equal to du 2 times x plus 3 dx. So we got the x plus 3 dx. So that's there. The only thing missing is the 2. So we put the 2 in, 2x plus 3 dx, and x squared plus 6x plus 1, and 1/2 here. And now we've got our 1/2 u du, du over u. And again, now we have, whoops, that's not a 3. Natural log of u plus c. And then we do our substitutions. X squared plus 6x plus 1 plus c. And that's our answer. One of these days we'll get one where we can factor. And lastly, let's see. No, we got a couple more actually. So let's take a look at these. This one looks interesting. We got a minus bx to the minus 1/2 dx. So let's take the integrand and say u equals a minus bx du equals minus b dx. And so dx equals minus du on b. So this is equal to u to the minus 1/2 du on b and negative. And this is minus 1 on b u the minus 1/2 du. And now we do our integration, minus 1 on b, and that's u to the 1/2 over 1/2 plus c, and that is equal to 2 on b u to the 1/2 plus c, and finally b a minus bx to the 1/2 plus c. And that's what we got. That's our answer. And we're in good shape there. So far these have been pretty straightforward. And let's see what we've got. My voice is getting a little weaker. Now, oh, here's a cool one. We've got, let's close that up, tangent to the 5th x secant squared x dx. So what we say is u equals tangent x du equals secant squared x dx, and this is then u to the 5th du. And that becomes very simple. That's 1/6 u to the 6th plus c equals 1/6 tangent to the 6th x plus c. And that should be the answer. And now, that was it. That was it. The next topic is definite, oh, wait a minute. This is more indefinite integrals. Let's see. We're going to look at something like this, and then I think we're going to call it quits because I'm getting pretty weary. So we have e to the ax plus sine to the bx plus c on x dx. Well, we can break that up into three different integrations. So we got e to the ax dx plus sine of the bx dx plus c on dx on x. This one, last one, is simple. That's simply the ln of x. But the first one, let's take a look at u equals ax, du equals a dx, dx equals du on a. So we have 1 on a, e to the u, du, plus, now for the sine, we have, let's say p equals bx and dp equals b dx, dp on b equals dx. So we have 1 on b, p, dx, dp, dp. And this one already is c ln x plus c prime, c naught. And now we can do our integrations here. 1 on a, e to the u, plus minus 1 on b cosine p plus c ln of x plus c naught. We can combine all the constants. We've got 1 on a, e to the ax plus, or that's a minus, sorry, minus 1 on b cosine, and p is bx, plus c ln x plus c combined. We'll say c prime. And let's take a look at the answer. We got 1 a to the ex minus 1 over b cosine bx plus c. And that's our answer for this integral. So I think we'll, at this point, call it quits. We're going to be doing, like I said before, a lot of integrations, a lot of them. And so, and in this case, we've got, oh my, we've got a ton. We're going to be looking at inverse trigonometric functions. We're going to, wow, we got some cool stuff coming up. So with this, we'll end for the time being, but we got plenty more integrals to do. And we got some really interesting things that will be coming up. different methods of integration, trigonometric substitutions, and all kinds of cool stuff, volumes of solids, and all kinds of neat things, densities and moments. So hang tight, and we've got a lot to do, especially if you're interested in physics and the sciences. We've got plenty of good stuff coming up. So hang in there and stay safe. Wash your hands and wear masks, social distancing, and take care.